Hi, in this video, I will be walking the viewers through the process of writing your own aggregate function in MySQL or MariaDB. Before we begin, I'm going to first show a demo of the final function in action, and then I'll explain why we need to do what we need to do. So MySQL and the SQL standard defines a number of aggregate functions like sum, average, or sum and average come to mind, but in MySQL, there isn't an easy way for you to just define your own aggregate within the actual server, like SQL console. And I noticed this when I wanted to use the product. I thought it would be cool to multiply all the numbers in a group, but there isn't. You can't just define a function like you would another function in MySQL. So I'm going to do a quick refresher on how these aggregates work. So you have the table T, it has a column name and value. So if you look at the sum, it just takes all the rows which the name is D and adds those together. So 2 and 5 is 7. You see that over here. 10 plus 1 is 11, but it doesn't have, there's no way to, there's no built-in product function. So in this instance of this is actually running MariaDB. I've already written and compiled my product function, so I can now do something like this. And you'll see that it works. If you go ahead and try running this command in your own MySQL instance, it won't work. So you'll see the answer. You see 10 and 10 here because 2 times 5 is 10 and 10 times 1 is also 10. We can also, you can always add things here. So I can always insert to T. Another 2. And now you'll see that the product of 2, 5, and 10, 2, 5, and 2 is 20. You can see that over here. I'll zoom in. Okay, so that's the intro. Now I'm going to go through setting up the development environment and setting up the source code. I recommend using a tool called WSL Studio that you can find in the link in the description. It lets you manage WSL instances a lot more easily and create new ones as needed. I'm going to call this one UDF tutorial and Docker Hub and Ubuntu. So this is going to Docker Hub and getting the latest Ubuntu image. Once that's ready, what you can do is go to the directory that you want to work in, and you can create a new one. I already have an empty folder that I'm going to be working out of. Open in terminal, WSL. First of all, I'll show you that you can see that our new WSL instance is there when you do WSL list. That's how you know it's working. Go WSL D UDF tutorial. Okay. And then you can do apt-get update. That's just gonna make sure that you can install packages properly. And I do apt-get install wget. I'm installing some packages you're going to need for this tutorial, so make sure you're following along and installing these as well. Okay, once you do that, then you can do code dot. This is going to open up the folder we're working in Visual Studio Code, or I'm using Cursor as an IDE. And this is nice because then we'll share the file system and we can get nice IntelliSense working properly. So this is Cursor. We've got my file, and importantly, we're in the WSL. We have our file system, and right now the repository just has a README file. I'm going to walk you through the important file, the structure we need. So I'm going to create a folder called source, and we're going to create a file in there called product.cpp. That's going to be our source code, and I'm surprised this isn't installed already, but we'll install it anyway. We need another folder for, but you don't need that many folders. We need a CMake file. CMake lists.txt. This is important. And I think we can get away with, I'm going to create another full file called package list.txt. You don't need this file, but I'm going to be including anything that I'm installing here so that you can keep track of it when you look at the thing in the end. All right. All right, we're going to need app get install. Put it there like this. So yeah, I expect the user to manually just install these packages that you're going to need. I'm going to install them now as well, by the way. So apt-get install CMake, and these are some dev dependencies we need. Yeah, you can skip ahead. I'm probably going to speed this part up in the video. All right. So that was now let's install the build essentials. These are also just some standard things that you'll need to build software. And last thing, cross build essentials. All right, so the first thing I'm going to do in this source file is include some of the MySQL related things that we need. So we'll do this, and then you'll notice the IntelliSense doesn't work, which for this video, it's not a big deal, but I do want to get this working because it's worth it. So we need to create a file so that Visual Studio knows, VS Code knows where to look. So inside the dev container or inside our WSL instance, I'll show you that we do in fact have this package installed. If I go to cd cd home, cd user. Yeah, there we go. User cd include actually cd lib. No, I think it was include actually. Yeah. Yeah, you can see we have a folder called MySQL, and I go here. And so the headers are there, but our VS Code doesn't know where to look. So we're going to create another folder called .vs code that will store some configuration stuff. This really isn't necessary for the project, but it'll make things nicer. So this is called C_CPP properties.json, and just JSON configuration. And this is kind of nice that we can have some suitable defaults in there, configurations, and actually list within configurations name and then include path. This is the most important part actually here. Now I should just be able to do this. Right here. Yeah, nice. You got the. It looks like we have IntelliSense now. I'm not sure. I don't think it's working yet. Yeah, it's not working yet. We're gonna go user include /**. Now it's working. Nice. So that's really important. So all I had to do was add user include ***. So it looks in the mounted user folder, and now we can do IntelliSense. This is the important part. Now we're going to really focus on the source code. So I'm going to include 2 more libraries. That's it. And now before we start writing the source code, I'm going to pull up the MySQL documentation and explain what we're going to do. So basically, when we want to create a loadable function, we need to create a number of C functions that are going to be compiled, and they have to follow a very specific naming convention. So everywhere in this documentation, you can replace XXX with whatever our function name is. So in our case, it's going to be product. And we need to create an init function, a dinit function, clear, add. And I'll explain what each one does in detail. But essentially, what you need to understand is the order in which it's called. So first, the init function gets called. And then we call the clear function, which in the first time you're running it doesn't really matter. And then for each row in your group, the add function gets called. And once the group ends, we call the clear again. Once we've done everything, so they have explained over here. Add, and finally, after we've added all the rows in the group, we call our actual, like the function with our name. And when all the groups have been processed, then we do dinit. So this will make more sense once we start looking at the code. Another thing to keep in mind, everything has to be in extern C. This is really important because when you compile C++ code, I think the compiler will pick random names or won't always use the same names for the functions, but for MySQL to read the functions, it's going to have these very specific names. So now I'll go back to our code window over here. And I will first of all do extern C. And I don't know why I did that. So we're going to do bool. Yeah, the predictive text is just, it's so good. Look at this. It knew exactly what we're going to do. So it returns, basically you return true if you want to stop the execution of the function, like if there's some invalid arguments or something. So for example, we're going to do if, and this is a good point to explain how we access the arguments. So args is, it's a pointer to a struct called UDF args, which I'll do. This is where the IntelliSense comes in handy, by the way. We can see that it has these different properties, and one of the properties we're really interested in is the arg count. That's the first thing. args.arg count. If it's not equal to 1, we can say, oh, it requires 1 argument, and then return true. And here we can do return false. Okay. I don't know. Sometimes the auto typing is annoying because I don't know what it was trying to do here. But this part's important. You want the function to exit if you have less than 1 argument or more than 1 argument. We can change the source code later on, but for now this is what we want. And then also we want to create a struct that we can use in this code. So we'll create a struct here, and we'll call it, what do we want to call it? We'll call it, let's call it product data. And all we care about is double result. And so in the init function, we're going to create a new instance of is equal to a new instance of our struct. And here we do need to set this 1 is just because you're multiplying numbers, so you got to start at 1, and then actually we're going to do 1.0. This is important as well. Here we're going to do args. This is this part here, args. We're going to dereference and get arg type of the. No, we're going to. Real result. So this will let MySQL know that we want a real result. So that's a numerical. Whenever you say real, you can think numerical. And then this part's also really important. This init ID is a pointer that gets, you'll notice, gets passed in all the functions. So that we need that. So we're going to go here, ptr. And we do have to cast our pointer as a character this way, and then we'll have to recast it to our own struct type again in the other functions, but that's just how it is. Extern, see, why is it giving an issue here? I'm missing something. Okay, then we'll go ahead and create the clear function. Again, it's got all of these arguments, which, I'll just copy, I'll let that do its thing. So remember, this is called for a new set, new group. So every new group, you need to, God, again, like the predictive text is so good. It knew exactly what we're going to do there, but it's not perfect. So it doesn't know that I want to do this. So basically, for the struct that's being passed around, what we want to do is set the result back to 1 because it's a new group. And we'll go void product add UDF. And then this is the most important function because this is being called for each row in your group. And basically, first thing we're going to do is if the args is if it's null, we're going to return and then if not, here's how we're going to handle it. We're going to first create an instance of our struct, but really what we're doing is we are dereferencing the pointer and casting it to our struct. So remember, this is something that this is like sort of storing the state. It's not in the right data type, so we're turning it into our data type here. I'm missing. It's not liking the syntax for some reason. Yeah, ID. Yeah. So now here, all we're going to do is multiply it by the So let me explain. This part's also worth explaining. So remember, args it's a struct. So we have to first remember that it has a pointer to the arguments, but they're all characters. It's a character array. So it's stored as a string. So we go to the first argument and then we're casting it as a double, and then we're multiplying it by our result. And I'm just not sure why has no storage class or specifier. I don't know what that means. So I'm going to ignore it for now. And this is, yeah, that's better. And yeah. Next, we'll do, this is the function that gets called at the end of each group. So it actually returns the result for that group. So it also has the same arguments as here. Copy that over. Here, there we go. So again, we're taking this pointer, we're casting it to our struct. and then we're just returning the result. And finally, we got to write the dinit function that's just going to delete our struct. So throughout the execution of a query, it will create a new struct of product data, and in the end, it'll be deleted. At this point, I am concerned about this red line. I'm not sure what's going on there. Did I write something wrong? No, not quite sure what the problem is. Maybe I want. Oh, I think I just forgot the semicolon. There we go. There, look at that. These guys have a problem. Oh, and this is the spelling type. It's funny. Okay, how do I control R? No. Control H. Yeah. Data. There we go. There, right? Okay, that must have been confusing. I might have to re-record that. Okay. At this point, we have the source code that we want. So I'm going to do a git commit of that. Git's already installed. I'm not sure why it's not pushing it. Oops. Yeah. That's weird. That's annoying. Okay, so it seems that when I use WSL, it doesn't. The git doesn't work anymore. How do I? Maybe I have to install Git in my WSL instance. Maybe that's it. There we go. All right, and we go. Okay, at this point, we have our fairly simple source code, but we need to write our CMake list, or otherwise we won't be able to compile the code, which is what we really want to do in the end, right? So let's pull up my CMake list. Okay, so this code, I'm going to walk through it fairly quickly because a lot of it is stuff that I pulled off the internet, but I'll highlight the parts that are really important. So we need to write a CMake minimum version, and we're going to set the option to build on x86, and by default it'll be off, and we also want the option to build on ARM. This is important if you want to build it for different platforms. And the rest of this stuff, this part's important because we're telling CMake that we want to create a project called UDF project, and where our source code is, and that we want it to be a shared object. Now this next part I'm just going to copy. Don't worry about it too much. It's just setting up some configuration for the compiler. So I'm going to go here, and there we go. So I'll explain it though. So if you select build ARM as your option, and the host is ARM, then, and the host is not ARM, it has to set all this stuff up. If you do build x86 and your host is not x86, then it needs to set this stuff up. But I'm running on an x86 system, and I'm going to do build x86, or I'm actually not going to do any of the flags, so it'll build. But later on in the video, I'm going to build it for my Raspberry Pi, which is an ARM system. So I need to be able to build it for ARM. Okay, this is good. Once you have your CMake list ready, which I'm going to go commit that. Yeah. At this point, what you can do in the command line, this is really important. This is kind of how you build things in general when you're using CMake. So you're going to make a new directory called build. It doesn't have to be called build. You can call it anything, but I'm going to call it, it's normal to call it build. So once you're in the build directory, you do CMake ... and this looks at the parent directory, finds the CMake file, and this actually doesn't compile the code yet. It creates the files that we need, that the compiler needs to read. Our compiling system is going to be called make, so now we can run make. And that actually compiled our code and created this SO file, which we can test, which I'm going to show you now. At this point, you can see that we have our shared object file, and we can now go ahead and try to test if it works. So remember, I built it for an x86 system, so I'm going to run MySQL in a Docker container on the same machine, so I don't have to worry about the build. But then later on, I will show you this in running on my Raspberry Pi, which is in the beginning of the video. I'll open Docker Desktop. Is that done? The dashboard. Okay, good. So I already have MySQL Server as containers. Here, just a regular MySQL instance. I'll run that. Oh, gosh. All right. Okay, and then for testing purposes, I will just create a folder called testing, and we're going to define a Docker file in there for easy testing. So Docker compose.yaml. And in the file, we're going to set up a very simple MySQL instance. MySQL with these ports, and we're going to do dot plugin. Yeah, we'll give it an entry point as well. All right, let's see if that works. Now this part's a little annoying because we're in WSL, and I don't want to run Docker from inside here. So I want just my regular good old PowerShell to work here. So I might have to go to that folder again. Here under testing, terminal. That's surprising. I didn't think. I think when I have a volume, I don't need to create the folder, I guess. Try again. Okay. All right, great. I think it's working. So now I can go with Docker PS, and we can go with this container ID. You can go with Docker exec it bash. I can go with MySQL. That's it. That's not what I want. I want to go Docker exec. I want to go MySQL. Okay, MySQL p root. Okay, there we go. Okay, so now we're in the MySQL console, and here, okay, we need one more bash session for this. I need also cd user, and I can go to cd custom, And okay, good. Nothing's in there, of course, but you can see my screen. I'm going to be copying over our product file. There we go. That's really important. And now in the MySQL window, I'm going to do show variable like plugin. And I can see it's under user lib64 MySQL plugin. So if I go here, what I do is copy product to /user /lib64 /MySQL /plugin. All right. And before I do that, I want to show you what happens if we try loading the function. I want to show the error message that you would get. So if I go here and I try running this in MySQL, notice that it can't open the shared library because it doesn't exist. It doesn't have access to it. Now we're going to copy it. So now if I try running it, it worked. So now I can create a table, T, name, var 10, value, int, make a decimal. All right, now I can do insert into P, D, values, D, 12, D, comma 2, comma, let's go S, comma 10. Where did I go wrong? Okay, so D, comma 2. All right, simple numbers right now. We go select star from T. Yeah, you can see that it works, and I can do select name product value from T group by name. It works. Very nice. 12 times 2 is 24. 16 times 3 is 48. I'm going to show you how to get that and to prove that it works in a different processor as well, different CPU architecture. But at this point, you can see that we successfully wrote the source code and built a custom aggregate function. The code, I think, at first sight is a little confusing because there's no entry point. You need to know some specific things about how MySQL handles these plugins. But once you know these things, it's somewhat straightforward. We're just taking some data and we're multiplying it, and then we're accumulating that multiplication value.